Okay, Wildcats. Today we're looking at Tuesday, February 5th, solving square root equations on page 43. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, solving square root equations on page 43. Solving square root equations steps. Step 1, isolate the square root. Step 2, raise both sides of the equation to the power of 2. Step 3, simplify and solve. Step 4, check for extraneous solutions. All right. If you would, finish up your notes. Now your notes are updated. Let's take a look at the examples. All right, first, let's read the instructions. Solve each equation. Remember to check for extraneous solutions. Okay, step 1, isolate the square root, which it is. Step 2, we're going to raise both sides by the power of 2. Now, this becomes the power of 1, so you're left with 2x equals 6 squared is 36. We're going to divide both sides by 2. So x equals 18. Now we need to check. By checking, we're going to substitute x equals 18 back into the equation to see if it's true. So we have the square root of 2 times 18 equals 6. Well, 2 times 18 is 36, so you have the square root of 36 equals 6. Well, the square root of 36 is 6. 6 equals 6, so that checks. All right, let's take a look at example 2. Okay, now, first step is going to isolate the absolute value. Now, you see to the 1/2 power, but you have square root of x to the first power is the same as x to the 1/2 power, which is the same as square root of x. Okay, so that technically is a square root. Okay, so we're going to add 3 to both sides. So you get 2x to the 1/2 power equals 8. Now we almost forgot, that's in parentheses. Almost made a mistake. Now we're going to square both sides. Now 1/2 times 2 is 2 over 2, which is 1. Okay, so that becomes the power of 1. So you're left with 2x equals 8 squared is 64. Divide both sides by 2. So x equals 32. All right, so now again we're going to check. So with checking, we're going to substitute 32 back into the equation and see if it's correct. Okay, so, and I'm going to rewrite the to the 1/2 power as just a square root. So we have the square root of 2 times 32 minus 3 equals 5. Well, 2 times 32 is 64, so you have the square root of 64 minus 3 equals 5. Well, the square root of 64 is 8, so 8 minus 3 equals 5. 5 equals 5, so it checks. Okay, so finish up example 1 and 2. All right, let's take a look at example 3. Now here, to isolate the absolute value, we're going to divide that by 1, and we're going to cross multiply. So 1 times the square root of x plus 5 is the square root of x plus 5, and 3 times 4 is 12. Now the square root is isolated. We're going to square both sides. That becomes the power of 1, so you're left with x plus 5 equals 12 squared is 144. Subtract 5 from both sides. X equals 139. Okay, now we're going to check. So we're going to substitute 139 in for x. So that's the square root of 139 plus 5 divided by 3 equals 4. Well, 139 plus 5 is 144, so the square root of 144 divided by 3 equals 4. Well, the square root of 144 is 12, so you have 12 divided by 3 equals 4. So 4 equals 4, so it checks. Okay, let's take a look at example 4. Now, example 4, the square root's isolated, so we're going to square both sides. Now, example 4 is probably going to be the most difficult problem of the examples. So let's add some light to that. So x minus 4 squared is x minus 4 times x minus 4. That becomes power of 1 equal to x minus 2. Now we need to FOIL this. So x times x is 1x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16 equals 1x minus 2. Now, before we do anything else, we need to move everything to one side. So we're going to subtract 1x from both sides, and we're going to add 2 to both sides. So you get 1x squared minus 9x plus 18 equal to 0. Now, at this point, we need to factor. So we're going to do 2 parentheses. Now we know x and x make x squared. Now we need to find all the combinations to make 18 and combine to negative 9. So let's come over here with that. So negative 1 times negative 18 is a positive 18. Negative 1 minus 18 is a negative 19. That doesn't work. Negative 2 times negative 9 is positive 18. Negative 2 minus 9 is negative 11. That doesn't work. Negative 3 times negative 6 is positive 18. Negative 3 minus 6 is negative 9. So that means that works. So our combinations are negative 3, negative 6. Or factors are negative 3, negative 6. So that's x minus 3, x minus 6. And if you want to double check that that in fact is that, we can check by using the box method. So x minus 3, x minus 6. So x times x is x squared. X times negative 3 is negative 3x. Negative 6 times x is negative 6x. Negative times negative 6 times negative 3 is a positive 18. So you get x squared minus 9x plus 18. So that verifies that these are the correct factors. Okay? All right. So now we set each of these equal to 0. So x minus 3 equal to 0. And then x minus 6 equal to 0. So we add 3 to both sides. So x equals 3. And add 6 to both sides. X equals 6. Okay, so now here we're going to need to check each of the values. So let's first check x equals 3. So we're going to substitute 3 in for x. So that's 3 minus 4 equals the square root of 3 minus 2. Well, 3 minus 4 is negative 1. 3 minus 2 is 1. The square root of 1 is 1. That does not check. So this is not a solution. So we say that x equals 3 is an extraneous solution. And what we mean by an extraneous solution is it came out to be a solution, but when you check, it doesn't check. So that's what we mean by extraneous solution. Okay, so now let's check x equals 6. So we have 6 minus 4 equals the square root of 6 minus 2. Well, 6 minus 4 is 2. 6 minus 2 is 4. Square root of 4 is 2. So this checks. So x equals 6 is a solution. So if you would finish up example 4. All right, now let's take a look at example 5 and 6. All right, example 5, we need to isolate the absolute value. So we're going to subtract 8 from both sides. So then you get the square root of x. This cancels, becomes 0, equals negative 6. We square both sides. That becomes x equals negative 6 squared is 36. So now we need to check. Okay, so now we're going to substitute that into the equation. So square root of 36 plus 8 equals 2. All right, square root of 36 is 6. 6 plus 8 is 14. 14 does not equal 2. So we would say that x equals 36 is an extraneous solution. Because while that came out to be a solution, when we checked it, it didn't work. Okay? All right, let's take a look at example 6. So the square roots are isolated as it can be, so we're going to square both sides. And that's a little hard to see, so let me write it out. X plus 4 squared equals 5 square roots of x minus 20 squared. Now that becomes a power of 1. You're left with x plus 4. When you square something, you're multiplying it by itself twice. So that's 5 square roots of x minus 20 times 5 square roots of x minus 20. So then you're left with 1x plus 4 equals 5 times 5 is 25. And the square root of x minus 20 times the square root of x minus 20 is just x minus 20. Now we solve for x. So we get 1x plus 4 equals 25x minus 25 times 20 is 500. We're going to subtract 1x from both sides. So we get 4 equals 24x minus 500. We're going to add 500 to both sides. So 504 equals 24x. We're going to divide both sides by 24. So x equals 504 divided by 24 is 21. So x equals 21. Okay, we don't have much room, but we have, I think, enough room to check. So we're going to check x equals 21. Okay, so we substitute 21 in for x, so that's the square root of 21 plus 4 equals 5 times the square root of 24 minus 20. Now, 21 plus 4 is 25. The square root of 25 is 5. So 5 equals 5. The square root of 24. Oh, whoa, whoa. That shouldn't be a 24. That's a 21. 21 got in there. 21. 21 minus 20 is the square root of 20, or square root of 1. The square root of 1 is 1. So 1 times 5 is 5. 5 equals 5. So 21 checks. Okay? So if you would, finish up your examples and start working on your assignment and have a wonderful Wildcat